guys, welcome. Today we'll be talking about YOLOv11 Pose Estimation on Custom Dataset. So pose estimation is a task that involves identifying the location of specific points in an object. You can see here. So usually these points are referred to as key points. The key points can represent various parts of the object such as joints, landmarks or other distinctive features. From this example you can see this represents right shoulder, this represents left shoulder, this is left elbow, this is right elbow, and this is left palm. So you can see these points are key points and they represent unique feature of this object. So the purpose of this exercise is to predict these points for a particular object. Now for this exercise we'll be using this tiger dataset. So you can see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 key points on this tiger. And this is the dataset we'll be using for our project. Now let's understand the dataset format. So I downloaded this data and uploaded here. And if you can see this is the annotation file and this is the image. So for this image we have this annotation file, and you can see we have values from 0 and all these things. Now let's understand all these values in a detailed manner. So these values are class index, xy of bounding box, width and height of the bounding box, then px1, pxy. These are the xy coordinate of first key point. Now if we check the image, if we match that with the image, you can see. So if we take this thing as the first point, px1 and pxy, px1 and py1 would be the value for this point, and 0 is the class index, you can see, and the xy is the center of this bounding box, and width and height is the width and height of this bounding box. Another format we have here, that is class index, xy and width and height of bounding box, then px1, py1 and then p1 visibility. That means if we are considering this key point is visible, hence we can put that value here. So if you want to know the value of this visibility, you can go to this link. So here if v equal to 0, that means not labeled. If v equal to 1, that means it is labeled but not visible, and if v equal to 2, that means it is labeled and visible. So these are the information regarding this format of annotation file we have here. Now this is the format of dataset.yaml file. So here we have part 2 dataset, we have train folder path, we have validation folder path. Then here we have key point shape. That means in this tiger dataset we don't have any visibility value. Hence here we have a total number of 12 key points and we have two values, that means px1 and pxy for each key point. We don't have any visibility value for this dataset. And then we have this flip index. So this is the information regarding this dataset.yaml for pose detection, and we saw the information regarding these points. Now let's go back to our notebook. So first we are importing all required libraries here. Now this is the part to our dataset. After that we have created these functions to randomly select some images and plot all key points and bounding box information. You can see here. Now after this point we have this function to create dataset.yaml YAML file, and then we have this function to create train and validation split. So when we run that it will be like this. So out of 263 images, 211 will be in training and 52 will be in validation. So here we have also created dataset.yaml file, and if you want to see the content within that file, you can run this function, and this is the content within dataset.yaml file. Now after that, here we are installing Ultralytics. Then after that we are uninstalling W and B. So guys, here I did uninstall this because it was getting some issues during training. So if it doesn't create any issue for you, then you can keep it, otherwise uninstall it. After that, here we are downloading pre-trained weight files. If you want to download other models, you can go to this link and you will find all the available models. Now after that, here we are loading the model. Then here, this is our training command. So here we are giving the part to data sorter YAML. We are training for 5 number of epochs. Image size is 480. Project is this. That means this folder will be created. Within that folder, this Tiger Pose training folder will be created. And within this, all the files that will be generated during training will be saved. So if you go here, you can see training backup folder. Within that, we have this folder. And within that, we have all the files that were generated during training. And if you go to weight folder, we have our weight files. Now here, yes, so when you run this command, you will have all these logs. So here you can see we have a lot of other parameters that could be helpful during training. If you want to know more about all these parameters, you can go to this link. So here you can have all the information regarding all those parameters, so that it will be easier for you to understand what a parameter does in training, and you can put your own custom value. Now after that, this is the log epoch, this is epoch 3. So this will go for 500 number of epochs. So after the training, let's go here. Okay, so training has completed. Now if you want to see the files generated during training, you can use this function, and this will show all the files that were generated during training. Now this function is responsible for inferencing. So here we are giving the part to a folder, we are giving the part to model, we are giving that we want 20 number of images, and this is the output folder. We are loading the model here, then we are selecting 20 number of files randomly, and then we are doing inferencing on those files one by one. So if you run that, you can see we have our prediction here. Just a minute. We have our prediction. You can see we have both bounding box and the key points. Now you can get those files here also, res fields. Yes, you can see we have bounding box and we have our key points. If you want to export the model to another format, you can use this command, and if you run this, the model will be exported from pt file to best.onx file. So guys, I hope this was helpful. Please like, subscribe and share. I'll see you in the next video. Till then, take care.